Welcome. My name is Kevin Brogle, and I'm the Chief Scientific Officer here at Ascensio. I would like to walk you through our IP-GeoScape product and show how it can be specifically used by medicinal chemists. You see before you the Landscape tab of the TLR7 agonist IP-GeoScape. Each marker is an exemplified compound extracted from TLR7 agonist IP publications. They are colored by assignee, and the different shapes within the same color are different patent families from the same assignee. The examples are clustered together based upon similarity using our proprietary molecular numericalization scheme, and the clusters are grouped on the same basis. You will also note that there are unoccupied spaces represented by empty clusters. I will speak more on these later. When you see markers of different colors in the same cluster, it means more than one assignee are working on similar compounds. You can clearly see how similar these structures are to each other and understand why they were clustered together. As you can see, the landscape view is completely interactive. There's a set of filters on the right that allow you to mine the landscape. I would like to take this opportunity to point out that our IP-GeoScape is data agnostic. Any data connected to the assignee, the patent family, or the compound can be incorporated and used to filter. One interesting way to use the filters is to view only the compounds from one company. If you open up the assignee group, you can select them from the assignee list. I'll use AstraZeneca as an example. You can see that they occupy a number of different clusters spread out over the landscape. You can then use the filters to further see how AstraZeneca's chemistry evolved over time by using the priority year slider in the patent group. If you slide to show only their first priority year, which was 2005, you can see that AstraZeneca had 4 patent families with that priority year. When you look at the structures, you see that they all contain this adenine core. Just to let you know, left-clicking on the background will allow you to clear any selection that you have made. As we expand the priority range to 2007, you see more examples of this same chemotype. Still containing the adenine core. However, in 2009, a new chemotype appears in another part of the landscape. It is essentially an opening of the 5-membered ring portion of the adenine core. As we expand to 2010 and again to 2012, you see that they continued primarily to optimize this new chemotype in this new area. I do want to point out that we do have filters connected to the compounds as well. In this case, basic Lipinski rules and polar surface area are included. You can also use substructure searching to understand what scaffolds have been used and whether there are ways around current IP. If you do a substructure search using the benzazepine core, and I won't spend the time to draw it out, I will use it, I've already written it in here. If you do this search, you will find that 260 molecules from 3 assignees have this core. They are all grouped together, unsurprisingly, in one area. If I expand the substructure to include a substituent at this position, you see that there's been no change. All 260 have a substituent at that position. However, if we try looking for how many have a substituent at the neighboring position, here we discover there are none. This is important information for both avoiding the IP of others and potentially understanding the structure-activity relationships for a chemical series. While the Landscape tab is the primary display, we have others which provide different views and capabilities. The Competitive Overview tab shows the who, what, and when, and provides competitive intelligence. The upper left panel provides basic information about the IP-GeoScape, the number of patent families, number of signees, and the number of exemplified molecules it contains. At the top is a bar graph showing each assignee and the number of patent families they have. You can see AstraZeneca leads with 15, followed by Roche with 14. On the left is another bar graph showing the breakdown by priority year. This shows how interest in the target has changed over time. In this case, it has been steadily increasing since the first priority year of 2003. In the middle is the intersection of the two bar graphs. You can see when each assignee was active in the area. For instance, while AstraZeneca has the most patent families, they have not been active since 2012. The charts are again all interactive and can be used to filter the patent table at the bottom. The patent family numbers in the table are hyperlinked to Google Patents, and this enables you to review the claims, specifications, and the status as needed. The Analysis tab looks at overlaps in the intellectual property. I'm not going to spend time on this today, as this is a tab that's primarily used by business development professionals and IP professionals. The Medchem tab provides another view, this one useful for molecular design. Here, the view is tiled. Each tile, when selected, displays an image of the most representative structure from the cluster, which has been highlighted by the most common substructure in the cluster. This gives a simple but powerful representation of the contents of the cluster. Selecting a tile also results in the filtering of the compound table here on the right. This table displays all of the compound structures in the selected cluster and their associated data. On the Medchem tab, you can also clearly see those unoccupied spaces I mentioned earlier. These are spaces that are ripe for new molecules. If you select the tiles surrounding an empty space, you can see how the chemotypes on opposite sides of the unoccupied space can be merged to create new compounds. Lastly, you will see in the table a column entitled Chemical ID. If a compound in the IP-GeoScape has been cataloged by Chemical, it is shown here, and there is an active link to its corresponding compound report card. Back on the Landscape tab, there is also a filter that allows you to drill down to only molecules that are in the Chemical database, letting you understand which molecules they are and where they're located. Now, the Chemotypes tab provides a window into the chemical series being pursued by one or more assignees. It's an automated chemotype assignment and clustering process that allows an understanding of what chemotypes were active when and who is working on them. In the display on the left, each marker represents a patent from the assignee on the left axis, with a priority year from the bottom axis. Each shows the most common substructure for the molecules exemplified in that patent. Here in chemotype 0, you can see that each patent has a similar tricyclic system. You can also see, based upon the chemotype timeline here on the upper right, that this is a fairly recent chemotype. While it was first identified in 2003 by 3M, most of the effort around this chemotype has been in the last few years. You can scroll through the chemotypes on the left-hand display And each time you can select markers in either display and drill down to just those patents in the patent table. The last tab lets you look at the evolution of any particular assignee's chemistry over time, similar to what I did in the landscape tab, but from a higher elevation. The display shows each patent's most common substructure, positioned by priority year and color-coded by chemotype, and separated by the assignee. You can see the name of the assignee at the top. As we scroll down to AstraZeneca, you can clearly see how and when they switched chemotypes, working on chemotype 4, the adenine core, from 2005 to 2007, and then switching over in 2009 to their new chemotype, which was captured in chemotype 1. They did do a little work in a couple of other chemotypes in that time, but predominantly switched from one to the other. Thank you for watching this quick overview of how our IP-GeoScape product can be used by medicinal chemists. If you're interested in learning more about our IP-GeoScape product, have any more questions about what it can do for you, or would like a demo, please contact us through our website. Thank you.